Hey friends, software is everywhere, putting us devs on the front lines of innovation, improving people's lives, shipping new and better features, all while moving faster than ever before, which is where our friends at Raygun can help. Their powerful error and performance monitoring tools make it easy to get all the diagnostics you care about for your team's web and mobile apps. When there's an issue, it shows you exactly what's going on, who's being impacted, and how to fix the root cause, down to the specific line of code. See how your users are experiencing your website or app in real time and ship better code faster with confidence, knowing that Raygun will alert you to any new issues or regressions. Start a free 14-day trial of Raygun today and try it for yourself. It only takes a few lines of code, and their simple usage-based plans start at $4 a month, a small price to pay to get your team and users to love you. Visit raygun.com. Try it out. Thank me later. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Charles Petzold. He's the author of Code, the hidden language of computer hardware and software. And I had him on the show when the first edition came out, and now we have the newly revised second edition of Code, the hidden language of computer hardware and software. How are you, sir?
Good. We call this the Dark Theme edition.
So. I noticed that. Immediately, the front, it's exactly the same cover, the classic cover, but in dark mode. Was that a plan?
It was something that the publisher came up with, and they sent me a PDF of a proposed cover, and I said, yes, that's it. And that's about it. Usually the cover there's a lot of discussion about the cover. This time, no. They managed to get the lettering just a little bit bigger, but that was the only change.
Very cool. So folks are listening, of course, on the podcast. They may not be able to see us, but for those who are not familiar with the book, what is special about it? There's the word code across the front, but then there's a lot of other stuff happening on the front of the book.
Yeah, there's three little symbols representing code all jumbled together, and one is Morse code, the dots and dashes in Morse code. The other is the dots of Braille, and the other is ASCII codes. And for some people, it takes them a little while to figure this out. Somebody came up with Microsoft Press a long time ago.
And it's worth pointing out for the nerds in the crowd that it is ASCII. This is 7 bits, you didn't just put hex or 8 bits in there. I noticed that right away. The initial conceit of code, and when I'm on an elevator evangelizing code, as I often am, talking to strangers, trying to get them to buy your book, they say, what is this book about? And I say, well, my friends, it starts with 2 little kids and a flashlight, and by the end, you've built your own computer. Is that a fair elevator speech version?
That's a wonderful summary of it. Yes.
How did you have this idea? Like, why start with a flashlight?
This book rattled around in my head for about 10 years before I started writing it. I don't know exactly how it all came together, but I wanted to show how logic gates work. And today, logic gates are microscopic. They're on chips. There are a couple transistors wired together. And you can show transistors, and you can kind of explain how transistors work. But there's like quantum mechanics involved if you really want to get into the electronics of a transistor. Back in the early days, in the 1930s, they built computers out of relays. They were using relays that had been built for the telephone system for switching circuits. But relays go back to the 19th century, and they were part of the telegraph system. You wire up 2 relays together, and because relays only work with electromagnets and a switch, they're conceptually easier to understand. So somehow I got to that point. And of course, because the relays originated with the telegraph system, I started to think about Morse code. And I just went back and back and back until I reached a good starting point, which was sending Morse code over with a flashlight. And so Morse code is a good introduction to digital codes, and the flashlight is the good introduction to basic electricity, which then leads to the telegraph and the relays.
Mm-hmm. I think it's also worth pointing out that, and this is a compliment to you, is that you started with a problem. You didn't just declare that this is a thing. There was a defined problem. I want to talk to my best friend who lives in the next house over, and I got to figure out what to do. So there's, at its root, we're solving some problem, a very human problem, which is that of talking to each other.
That's the engineer in me. I think I inherited some engineering genes from my father and grandfather, two grandfathers. And so I think of a lot of things in life as problem solving. And I used to do that when I was writing the programming tutorials as well, pose certain problems and show one solution and then show a better solution and show a little better solution. So it's the way I think.
When did the first edition of Code come out?
1999.
Okay, so we're looking at 20 plus years, 23 years
Yeah,
here.
yeah,
The distance between 23 years pre 1999, like if you look at the 70s and roughly 2000, and then now a lot happened. Do you
yes.
feel that as much happened between 2000 and 2020 as did 1980 and 2000?
I think so. We really saw the growth of the internet in the past 20 years. The internet existed 20 years ago, but not the way it is now. We couldn't have been doing this 20 years ago. As you,
Seeing each other recording in a
yeah.
browser with no plugin, and it's all like high definition, high quality. Yeah, that wasn't the thing.
A lot of the first edition was based on antique technologies. A lot of it shows how logic gates work by wiring relays together. And when I went for a sample microprocessor, I chose the Intel 8080 and the Motorola 6800. Is that what it is? Yeah.
Yeah, 68,000.
68, whatever. Okay. So all these were antique technologies. So I didn't really, if I wanted to, I didn't have to revise the book at all. Because it still was readable. It was there were certain things that bothered me about it, but if I really chose not to revise it, it didn't have to be revised. It was still selling well, and people are still saying good things about it.
So was it more that the world changed, or was it more that you changed that made you want to make a second edition?
It was that there were certain things about the book that I wasn't happy with. There were certain things I could certainly improve on. And I was approached by a Pearson editor at the right time for me to really focus and do this right. It was I had nothing else on my plate, and I spent over a year and a half on the book and the companion website, which still isn't finished. So I'm still working on it.
Now, you have said publicly that when you started this book, you wanted to make a friendly 300-page book and
Yeah.
not a scary 400-page book. But I think what you've ended up with, though, is a book that's nearly 460 plus pages if you count but it doesn't feel threatening. How did you find that balance?
I don't know. To me, I still have in my head a 300-page version of code that doesn't go quite as far. One of the things that is different about this book to me than any other book I've written is that it could have been written in a variety of ways. And that is not the way I feel about all the programming tutorials, programming Windows editions 1 through 6, etc., or the annotated touring. To me, once I figured out how the annotating touring was going to be structured, there was really only one way to write it, and I'm still happy with that. There's very few changes I'd want to make to that, but this could have gone in a couple different directions, and so the first edition went in one direction, the second edition goes in another. I don't know. I don't have, you see, I don't have a lot of confidence that this is entirely the right way to have written this book.
That brings up a number of interesting questions. So sometimes second editions of books are, we went through and we fixed some errata, we added 5 or 10 pages, and otherwise, we tightened up the screws a little bit. This book is 68 pages longer. You've rearranged a dozen chapters. You've added entire new chapters that didn't even exist before.
Yeah.
And you're working on a companion website with, color diagrams and interactivity. That seems like a 2.0 version of the book.
Yes, it was substantial. If I was going to do a light revision, there were a few things I would have fixed. The first edition had basically very little discussion of Unicode. Unicode to me has been so important. We wouldn't have emojis without Unicode. Or you'd have emojis on the Apple and the iPhone, and you wouldn't be able to see them on the Android, something like that. There were some really stuff that had gone completely out of date. One of the examples of bits was showing in the first edition was showing squares on rolls of 35 millimeter film that indicated the ASA rating to the camera. Nobody has seen that stuff for for many years. So there were a few things I could have fixed, but I really want to go deeper into how a CPU actually works.
Mm-hmm.
In the first edition, there's a chapter called Automation, which shows how to design a circuit that can add up sequential numbers in memory. But there's a problem with that. What if you want to subtract some numbers? And so the solution is to put codes into memory. The following number is to be added. The following number is to be subtracted. The following number halts the computation. And once you do that, you're putting codes into memory. These codes are software, but because they're triggering signals in hardware, they're also part of hardware. So that's the merging of software and hardware down on the machine level, which to me is like the basic theme of the book. But from there, the first edition then jumped into a discussion of the Intel and Motorola processors from the 1970s. And I thought it was too big a jump. And I thought that chapter with the two microprocessors was deadly to read. When I tried to read the book, it stopped me dead and I couldn't go any further. And I became convinced that people were getting to a certain point in the book and saying, oh, I get it. I don't have to read the rest of it. And I hope they were doing that so they wouldn't waste their time with a lot of the other chapters. But so I wanted to fix that. And the way I fixed it was to go deeper into how the CPU works. So there's chapters on the arithmetic logic unit, the chapters on how numbers are stored in the computer in registers, and there's a chapter on all the control signals, and basically putting together a subset of the Intel 8080.
And now a word from our sponsor, BetterHelp. One of the things that came out of COVID wasn't just the ability to do remote work, but it was also better remote therapy. And BetterHelp is the world's largest therapy service. They've had over 5 million video sessions, calls, chats, and messages every month. They're on a mission to make sure that everyone has easy and affordable and private access to high-quality therapy. It's a really great thing that we talk about here on the podcast is mental health, how important it is, especially as so many of us engineers have a feeling of imposter syndrome, and we get overwhelmed. And it can be tough to have your brain stay in that problem-solving mode when you're facing with a particular challenge in life. And often a therapist can help you become a better problem solver and make it easier to accomplish your goals, no matter how big or how small. Being able to connect to a therapist with a tool like BetterHelp is a great option. When you want to be a better problem solver, therapy can get you there. Visit betterhelp.com/HanselMinutes today to get 10% off your first month. That's betterhelp.com/HanselMinutes. There's a classic meme. I know you're not big on memes, but I'll paint the picture for you. That says, let's all learn.
Memes are.
I know. Let's see if you know this one. The meme says, let's learn how to draw an owl. You draw a circle for the top part of the owl, and then you draw the bottom part of the owl, and then the next has a perfect picture of an owl. So then now draw the rest of an owl. I'll give you that the first version of code, somewhere around chapter 18, you introduce an abacus. And then you draw the rest of the owl. Yeah. And holy crap, it goes right into, it's a roller coaster. You go right into the microprocessors. Yeah. And I think that you're very thoughtful to indicate that, it ramped up real fast. And you've solved that problem with like 5 new chapters. You go very gently up the slope through, registers and buses, much more slowly. And then you get a little bit even more holistic. Peripherals and the operating system, and then a whole new section on JavaScript, which honestly surprised me. But I thought that it was very timely.
Me too.
Well, I know you have strong feelings about JavaScript, but it's the language we have.
Yes. In the first edition, I wanted to choose a representative programming language. And what I chose was a language that nobody uses anymore, but was very influential, called Algol. And Algol was really the granddaddy of all the structured languages, like beginning with C, etc. In this edition, I wanted to allow the user, the reader, the user, I was thinking of software, that I wanted to allow the reader to actually experiment with coding without downloading anything. I wish. You know how the early PCs had a built-in BASIC?
Yeah.
You know, I wish the PCs still had that, and I wish the the Macs had that. And if the Macs and PCs had the built-in BASIC, that's what I would have used as my representative language. But the only language that you can experiment with on your desktop machine without downloading anything is JavaScript. And the way you do it is you write little HTML in text files and you load them into your browser. You want to hear a confession?
Please.
Okay. Up until I started writing this book, I had almost no experience with JavaScript. I am a hardcore desktop programmer and then merged into a mobile programmer. But to me, the programming languages are C and C sharp. Those are the two biggest languages I've used in the past decades. I don't want to count them. But I wanted to have a companion website for this book. How to do that? Well, if it were 10 or so years ago, I would have been doing it in Flash, or I would have been doing it in Silverlight, which I liked a lot. But both of these are gone, basically. And the only real way, there might be other ways, but the standard way to do interactive graphics in in a browser is with JavaScript and the HTML5 canvas. And so that's what I learned. And had fun doing it. The HTML5 canvas I found not very difficult to learn at all because I had experience with several graphics programming languages over the years. So the API was not hard for me to grasp.
Yeah. Well, I mean, I one of my first applications I ever wrote in I want to say the late 80s was upon a Palm Pilot. And, once you figure out where 00 is and you figure out where the X and Y's are, at that point, you're pretty much on your own and you go have fun. So the canvas is the same way. I do actually want to call out something fun that you wrote on your blog, and I want to do a dramatic reading of this.
Okay.
I love this. Okay. So this is Charles Petzold discussing the changes of the second edition of code. And he says, I wished dearly that the Mac and Windows came with built-in basic environments. If that were the case, this chapter would have been basic, but I didn't have that freedom. My hands were tied. There was only one real choice. My free will meant nothing. I was forced into JavaScript. And the only consolation is that I'm not the only person in the world forced into JavaScript. There are literally millions. What's your beef with JavaScript, Charles Petzold?
I really prefer strongly typed languages. I really like giving the compiler a fighting chance to figure out what's wrong with your program before it's running. Yeah. It's as simple as that. It's
right. The error happens like at runtime and we all suffer, or it happens up front and then only the programmer suffers.
I know there are ways to wrap JavaScript in better languages. I didn't want to mess with all that. I was working with a deadline. I missed the deadline by a year, but I was working on a deadline.
Yeah. Okay, so here's a question. I've been focusing the last several years of my life trying to get, young people, early in career people, career switchers, not necessarily young, but of all ages, excited about programming. And one of the analogies that some people think I overuse is the conversation around an automatic shift car or a stick shift car. I'm currently trying to teach my son to drive, and he doesn't want to learn to drive stick because there are no stick shifts in the US. But overseas, half the cars are stick shift. And I think that you're a better driver if at least you know how to drive stick once. I'm not saying you need to suffer. So then the analogy goes, do we make the young people suffer with assembly in C and then we give them garbage collected languages? So to the point of code, does the average developer who's starting their career need to read a book like this, or are we just teaching them to drive stick when there are no stick shifts?
That's a good question. To me, when I first was learning C, the concept of pointers was so obvious to me because I had been working with addresses in machine code and assembly language for several years at that point. So I didn't have any problem with pointers. I had written programs in assembly languages that used tables of pointers and pointers to pointers and all that stuff that you use in C. Now, at that time, I would have said, if you want to be a good C programmer, you should be coding in assembly language first. Nowadays, in high level languages, you don't encounter pointers that well. If you want to use them in C sharp, you have to do something special. And that obvious example doesn't work anymore, unfortunately. But I still think that people benefit from understanding what's going on inside the box.
I don't want to see the reason I struggle with this is I am aware now of my over 30 years in the biz and my age, and I don't want to be a gatekeeper that prevents a young person from saying, well, before I let you put a text box over some data, I need you to write a doubly linked list from scratch on a whiteboard, right? But I think that there's value in this. And that's what I think is so great about code is that it starts gently and by the end you get it, but you don't have to do anything with it. Code doesn't ask anything of you. The book doesn't say, and now take this to work and be a better database programmer. You know what I mean?
Yes. After the first edition came out, I heard from a bunch of programmers, experienced programmers, professional programmers who did not know this stuff, who really could not tell you how a computer added two numbers together. So to me, that was the important thing that I wanted to get to. And if somebody's reading code and they get to the point where they get to the chapter where you add two numbers together and say, "Oh my God, that's amazing!" And I don't have to read the rest of this. That's fine with me. That's fine. But you should at least get to that point. People should know how logic gates work. Really.
Yeah. And I think that there's a way to do that is both inclusive and welcoming of new people. Like whether it be my son, I want him to learn how to change a tire. He can probably call AAA and he can get someone else to change his tire. But I think that change a tire at least once. So then you have that experience. And I think putting a couple of wires together and learning about transistors and learning about capacitors and resistors, there's value in all of that, even though your day job might be in JavaScript. Which brings me to the website, codehiddenlanguage.com. It's the companion website for the second edition of Code. It looks like you're building this in a very modest, just works kind of way. I noticed that you're not using a fancy JavaScript frameworks. You're not building the whole thing out in Bootstrap. It's just you and the code. Was that a plan as well?
It was possibly resulted from my ignorance of JavaScript. I did not realize that in order to code in JavaScript, you had to use, libraries called JMagick and JDo this stuff and JDo that stuff. I just didn't know. And so I just did it. It's I did use JavaScript classes, which to help me with to encapsulate the workings of the various logic gates and stuff like that.
Well, one of the cool side effects that maybe you thought about or maybe you didn't, but you might be impressed to learn is that when you go to codehiddenlanguage.com, for example, I'm on chapter 6, logic with switches. You can, and my children have, as they've been reading the book, right-click and view source, which is how so many of us learned how to program. And it's not minified or squished. You didn't hide any of this. You didn't run it through a minifier, which means that you can learn code by stepping through the examples in the companion book, which I found really enjoyable as well. And kind of a little bonus I didn't expect I would get.
If people are doing that, I'm going to really have to clean up that code a bit because it's kind of dirty at this point.
But it is fun because it's an interactive version of the book, right? It's live.
Yeah.
And it looks like you're still working through that. I made it about 22, 23 chapters in, and the website is a living experience. You've got some pretty sophisticated stuff going on there.
Yeah. Towards those chapters where I'm actually showing how the CPU comes together. It's giant stuff. I hope you have a humongous screen to view the whole graphic.
Yeah, chapter 22 on the register array and the CPU control signal starts getting pretty darn interesting. And it's an impressive bit of JavaScript code as well.
Thank you. Thank you.
Yeah. It's funny that you were mentioning before that you wished computers had like dropped you into like a command prompt that has like, basic or whatever, because I recently, in the last couple of weeks, have been building out a Commodore 64 for those that are
Yeah,
on the.
I've seen some of
Have you been watching that?
your yeah.
Maybe
This
I'll
is
get you on TikTok at some point. But it's been just a really enjoyable experience. And I'm trying to figure out if it is nostalgia and a simpler time that is driving me, or if it's a reassertion of, do I know this stuff? I hope I know this stuff. And I've decided that it's somewhere in between. And that's why
Hmm.
I'm rereading code at this point, is just to remember if I know these things or not. And
Okay,
I've enjoyed that.
that sounds good. I'm not particularly interested in nostalgia.
Hmm.
When people start talking about programming on the original IBM PC and do it, the hassles with memory allocation and all that, I just kind of walk out of the room. So I'm not nostalgic in that sense. I haven't gotten into retro computing at all,
Mm-hmm.
but I respect it. So I'm not sure where I stand in all this. It's interesting that I use the Intel 8080 as my processor, the sample processor. The reason why I picked the 8080 is that it was the one I was most familiar with, but I've never actually coded on an 8080. My experience with the 8080 is with assembly language and machine language is because I coded on a Zilog Z80, which was a superset of the Intel 8080. I originally got familiar with this stuff because I was building a computer in the late 70s and early 80s that powered electronic music synthesizer. There's a little essay about this on my website. I think that at one point I was at the technology section in the Barnes and Noble, and this would have been the original Barnes and Noble store before it was a chain on 17th Street and Fifth Avenue in Manhattan. And they had a great little technology section there in the late 70s. And I think that the book about the Intel 8080 was in stock, but a book about the Motorola processor was not in stock. So I think that may have been how I originally got into the 8080, and then eventually the Z80. And then my first store-bought computer was a Osborne One, which also had a Z80. But the 8080 to me represents about as simple as you want to get with and still be able to do something. I mean, Intel had 4-bit processors before that, but they were good for embedded systems, but not for real programming.
So you're not into the nostalgia. You're not going to go and build. They have Osborne kits now. You can get and build your own Osborne for your desk. I know, Dave Plummer and some other folks are going and doing stuff like that. But I'm curious. You could go and create an 8080 entirely in JavaScript now and emulate it entirely in the browser. That could be the end of.
Yeah, I have done that basically.
Yeah,
I haven't put a UI on it, but I have done that. I don't know how far I want to go with this because I think there are other sites that have 8080 emulators that
of
probably are
course.
better suited for experimentation. But there's a CPM source code, so you could, in theory, load the source code into the 8080 emulator, the CPM source code into the 8080 emulator, and have a CPM system emulated. I don't know how much time I want to spend with this personally in building this thing. I hope that if people get interested in it, they search out better ways to experiment with some of these early processors.
Mm-hmm. So the latest book, the one that we were talking about, is The Hidden Language of Computer Hardware and Software. It's the second edition of Code. You also have written the annotated Turing. I spoke to you 4 or 5 years ago about some thinking that you were doing around analog computing and the computer of the tides. Do
Yeah,
you have more books in you?
yeah. I hope I have a couple more books in me. They're going to take a while. I like books to rattle around in my head for a long time and figure out how they should be written.
That's fantastic. Well, we appreciate that you let this one escape. We're having a lot of fun with it. You can check it out at codehiddenlanguage.com. Click on the introduction there, and it'll tell you where to get the book. Everywhere that books are sold, pick it up in person because it's a lovely physical book. And of course, enjoy the companion site at codehiddenlanguage.com. Charles Petzold, thanks so much for chatting with me today.
Oh, thank you. Thank you.
This has been another episode of Hansel Minutes, and we'll see you again next week.